Bismillahirrahmanirrahim. Assalamu alaikum everyone. In this video tutorial, we are going to extend our knowledge of about time operations. In the last 7 to 5 video tutorials, we are discovering about time operations in both domains, continuous time or in discrete time domain. Right. So we have seen the effect of individual time operation, and in this video tutorial, what I'm gonna explain you, and this is very critical and very important lecture here, that once if one is going to apply multiple operation, right? I'm interested here, multiple operations application or multiple time operation application. That means if a signal x of t is given, and I'm not only going to apply the time scale, rather I'm also going to apply time reversal as well. Furthermore, not I'm not only going to time scale any signal, but also time shift as well, or time shift will also be applied with the sequence of the time reversal. So what is going to be the final result? Or does the order in which we apply these two signals? For example, one can choose time scale first and then time reversal, or one can use the reverse order as well, or one can choose time scale first or time shift or the reverse order, right? So is this order actually affect the final result or the final result, irrespective of the sequence of the or the order of the operations or the multiple operation, the result will remain same. So this is the key question that we are going to answer today. And if there is a sequence or specific order present in between the multiple time operation applications, then one need to be very careful. So in this lecture, what we are going to observe, we are going to test time scale and time reversal in different order. For example, one can actually, we are going to apply time scale first, then time reversal, and then in reverse order. And then we are going to check time scale and time shift in the two different orders, and then time shift and time reversal. And we're gonna test this question, this key question, that this change in order or this order change will affect the final result or not. And this is the key question we are going to answer here, right? So let's start and move to these different combination of time operations one by one, and then we will conclude our lecture. Okay, in this slide, I'm going to compare the combination of the time operations, and I'm going to choose scale and uh, reversal operation, right? So first of all, let's say that we are going to apply scale, and then we're going to apply time reversal, right? So let's say our signal is what, x of t, right? And if we are going to apply the time scale operation, definitely it will become what, x of at, right? And then we're going to apply the time reversal operation. That means t will replace with minus t. So x of at would become what? X of a, and t will replace with minus t. So that means uh, the output would become x of minus at, right? This is the output. So let me note it down, and then we will apply the reverse combination of these two operations. So this is the output when I've noted it down, that first we applied what, x time scale, then signal become x of at, and then time reversal, the signal become t will replace by minus t, so signal become x of minus at, right? So let's apply the different combination. And for this time, we first apply the time reversal, and then we will apply scale, right? So if we are going to apply the time reversal first, so what is going to happen? X of t will become what? X of minus t. And then we are going to apply time scale operation. So what is going to happen? That x of t will replace with at. So result will be minus at. So if I note it down, so this is what I've just noted down. So if you see the earlier sequence in which we applied the time sequence first, time scale first, and then time reverse it, the result was x of minus at. And in the next sequence, when we first applied the time reversal and then we applied the time scale, the result is still x of minus at. So the conclusion is if you apply irrespective order these two operations, scale and the time reversal, the output will remain same. Order does not affect the final result if you are applying these two operations. Okay, let's talk about the time uh, operations and combinations, and we are discussing now scale and time shift. So whenever we scale any number, then we replace x of t with x of at. That means scaling factor is what? Scaling factor is at, right? And similarly, when you are going to time shift any operation, so t will be shifted by tau units. So x of t would become x of t minus tau, right? So let's say scale is our first operation and time shift is our second operation. So what is going to happen, right? So x of t would become, first of all, we scale it. So it will become what? X of at. And then we apply the second operation. So x of t, x of at will shifted by tau unit. That means it will be something like that. A will remain same, t minus tau would be there. So it will be in general equal to x of a t minus a tau. That will be the final output of uh, time operations if we apply first scale and then we apply time shift, right? So if I'm going to note it down, that was the output when we applied first scale operation and then we applied this time shift operation. So this will be my first operation and then it will be my second operation time scale. So let's see what is going to happen. So original signal, we know that it is what? X of t. So when we time shift any signal, it will become what? X of t minus tau. And then we will apply the scaling operation. And remember that scale is done or scaling is performed on the time variable, which is what? T here, because tau is not time variable, it is a shift or amount of shift in the time, right? So when I'm going to apply the time shift operation, sorry, time scale operation on this specific variable, so what is going to happen? It will become x of at minus tau. There will be no change on tau, right? Okay, so this is the output of x of t when scaling, when shifting is done first and then scaling is performed. So this is the output. So let me note it down for you, then we will compare. So this is the two different output. We can see that for in the first pre-sequence or first application of time operations, first we choose the scale and then we choose shift operation. So the output of was this thing, right? X of at minus a tau. So it has some output. So the output was x of at minus a tau. While it is not equal to the case when we applied first shift and then we apply the scale. So that output is was x of t minus tau. So that means this there is the conclusion. If you apply two different operation, time operation, and those are scale and shifting operations. So if you choose them in the different order, the output of the signal or the output of the time operation application would be different, right? So we can understand that x of at minus a tau is never equal to x of at minus tau, which means that uh, we must be very careful when we applying these two operations in same system. So we need to be very careful when we are choosing their order, because we are expecting different output and it may occur a different output. Okay, now in this slide, I'm going to again check the time operations combinations. And in this time, I'm comparing time shift and time reversal, right? So what if we apply these two operation, time shift and time reversal on any signal and in a sequence, right? So what will be the effect on the final result? Let's see. So let's say, first of all, I'm going to apply the time shift and then I'm going to apply the time reversal. So if I want to apply time shift first, so x of t would become what? X of t minus tau. And then I'm going to apply the time reversal. That means what is going to happen? T will replace with minus T. So final result would be what? Minus T minus tau. So this will be the final result, right? And if we choose the final version, if we choose the reverse order, so what is going to happen? In reverse order, first of all, we will apply what? Uh, Time reversal, and then we will apply the time shift. So what is going to happen? First of all, the signal will be what? X of t. So if we apply the time reversal, it will become x of minus t. And then we will apply the time reversal, then the signal would become what? X of minus, and t will replace by t minus tau. So eventually, if you simplify it, it will become x of minus t plus tau. And if you carefully notice, this is the final result of the next sequence, and this is the final result of the first sequence. In the first sequence, we applied first time shift and then reversal. In the next sequence, we applied the time reversal first, and then we applied time shifts. And both of these results appear as a different result, right? So that means the time shift, whenever it is compared with the time reversal, the order actually matters. And uh, irrespective order, different order actually produce a different result. So that means uh, if one is going to carry out these two operations on the same signal in a sequence manner, then one has to be careful what he or she actually wants to do with these signals, and these orders or application of these orders will actually produce two different signals. As in this case, we can see that in the first case, the result was x of minus t minus tau, and then in the next case, x of minus t plus tau. Okay, this is the final slide of overall lecture. And in this lecture, what we did actually, we compared the time operations combinations, right? Or we actually compared the application sequence of the different time operation on the same signal. What if we apply a time scale first, and then we apply the time reversal, and then we actually tested this is in reversal operation or reverse sequence, time reversal and then scale. So we noticed that there was no effect on the final output. The final output remains same, right? So irrespective of sequence of application of these two time signals, output will remain same. Then we tested time scale and time shift, and in two different sequence. First we applied scale and then shift, and then we applied first shift and then scale. So we saw that the output was different. That means order changes the result. This is true here. So that means if you choose the different sequence of these two same signals, you are going to observe the different output, right? And then we tested the other other operation or other combination, time shift and time reversal. And here we also noticed that this was also yes, because that if you apply the time shift operation and then you apply the time reversal, you have a different output. Or uh, and if you choose the time reversal first and then time shift, then you have a different result. So basically, order of application of these two operations or time operations, order changes the result. This specific order actually change the result, and this is very important phenomena for anyone who is going to apply the different combination of the time operation. So he has to take care of these three uniform results, that when and if I want to further extrapolate these conclusions, then I need to actually notice a very important fact, that whenever time reversal is involved with the time scale, you won't see any change in order, right? You won't see any impact of change in order, right? But whenever the time shift operation is involved, you have a yes, and here you have also time shift operation, you have another yes. So basically, time shifting operation is a critical operation or a critical time operation. And if you are applying this time shift with any other time operation, you may apply time shift with time scale, you may apply time shift with time reversal, you will have to be very careful, because order of the application of these two operations, uh, uh, or any other operation with the time shift, will actually affect the result very severely, right? So that means whenever you have involvement of time shift operations in time operations, so you must be very careful in what sequence you are going to apply the time operations, right? And or you need to be very careful what sequence you should choose to apply the time shift operation, right? So I hope you have understand the key phenomena of combination of time operation in this result. In this video we have just covered this specific property of time operations, how they actually impact the signals whenever they are applied with a different combination of other time operations. So I hope you have understand this complete lecture. Still, if you have any confusion and query, you can post your queries in comment section. Thank you so much for listening.